On number 40, we want to add these two expressions that involve m and n, and it kind of looks like a pain because of all the different m's and n's floating around. But remember, our goal is to get a common denominator, and then it's not too hard to add these two together. So what I'm going to do is I'm going to try and factor everything I can before I move on. M minus n, nothing to factor there. M squared minus mn minus 6n squared, because this is a trinomial, and the leading coefficient is 1, the number in front of the m squared is 1, this is the relatively easy kind of factoring, right, where it's going to be m, n. Now notice that because the middle term is an mn and the last term has an n on it, when we do our magic numbers here, we're going to need n's there so it FOILs out correctly. So I want two numbers that multiply to negative 6 and add to negative 1. I can make a factor tree for negative 6, and I would find that negative 3 plus 2 would be my two numbers. So negative 3n plus 2n. If that's difficult for you, you could also do TPTS by saying, okay, 1 times negative 6 is my target product, negative 1 is my target sum. Split the middle term and go from there, but it shouldn't be too bad. Now 3m minus 5n I can't factor. But in the denominator, m squared plus mn minus 2n squared, similar to what I did before. It's a trinomial, it has three terms. The number in front of the m squared is a 1. So I can factor this, two things that multiply to negative 2 and add to the understood 1 in front would be negative 1 and positive 2. So m minus n, m plus 2n. Alright, so now I look at my least common denominator. I want to know what that is. So what is my LCD? The way we find our LCD is we look at all the factors that appear across all the denominators we have. In this case, we only have two denominators. And I just list those factors. M minus 3n, that's taken care of. M plus 2n, that's going to be part of it. M minus n. We have the m minus n, so we want to copy that down. And I already took care of the m plus 2n, so I don't need to put that again. The only thing you have to look out for is if you have a power on a factor, you want to make sure that your LCD has the highest power of that factor that appears. So let's go ahead and write these fractions. I always start with my LCD, m minus 3n, m plus 2n, m minus n. Now I compare what I had before to what I have now. So this was my denominator, m minus 3 and n plus 2, and now I have this. And I notice that I picked up an extra factor of m minus n, so I need to also multiply that in the top. So I'm multiplying with an extra m minus n. Same thing here. I notice I picked up an extra factor of m minus 3n, so I need to multiply that with what's already in the top. Remember in class I said that if you were to cancel top and bottom here, you would see that you start with exactly what you began with, which is something we don't want to do because we'd be working in circles, but that's the idea, to check your work. Alright, now these have the same denominator, so I can put these all under one big, or all over one big m minus 3n, n plus 2n, m minus n. Okay, FOIL here. N squared, you'd end up getting a minus mn minus mn, which is minus 2mn, plus n squared. FOIL here, you would get plus 3n squared, minus 9mn, minus 5mn, plus 15n squared. So we have all this stuff going on. Let's see if we can combine any like terms. M squared and 3m squared is 4m squared. Minus 2mn minus 5mn, and then minus a 9mn would be negative 2 minus 9 is negative 11, minus 5 is negative 16mn, and n squared plus 15n squared is 16n squared. Now the last thing we want to do is factor the top and just make sure we're not missing anything important. we can cancel out. So I can factor out a GCF of 4, leaving me with m squared minus 4mn plus 4n squared, m minus 3n, m plus 2n, m minus n. And if you were to factor the top, using the factoring we did before, two things that multiply to positive 4 and add to negative 4 would be negative 2 and negative 2, so I could say m minus 2n, m minus 2n, and nothing here actually ends up canceling. So the last thing I can do to condense this at least a little bit is say m minus 2n squared. It's a perfect square trinomial, so you also could use that kind of factoring. And this would be my answer. Always look for opportunities to cancel top and bottom after you add them together.